Hello, and welcome back to the GWSDAT tutorial series. Today we're going to be covering the GWSDAT Excel plugin. This video specifically covers the use of the plugin. For installation of the plugin, see video 2.2 Excel plugin installation video, linked in the description below. The first button here is New GWSDAT Sheet. This inserts a blank GWSDAT template into the current workbook. Insert Shapefile opens your file explorer for you to choose a shapefile for the project. Analyze begins the GWSDAT analysis on your data. Pressing Analyze will first give you a terms and conditions to agree to, and then some add-in data processing options, which we'll go over later in the video. Restore Session will load a saved session. The saving process will be covered in detail in video 4.9 Save Session. There are two examples which can be opened. Basic example, which inserts an example GWSDAT worksheet dataset into the workbook, and comprehensive example, which inserts a more detailed example worksheet, including site plan, NAPL thickness data, flag solutions, and multiple aquifers. The user manual opens the GWSDAT manual in the user's web browser. This requires an internet connection. About GWSDAT will show version information, terms and conditions, and licensing information for the plugin. And finally, update or check to see if there is a newer version of the GWSDAT plugin. If it exists, it will be installed. This also requires an internet connection. When selecting Analyze, a pop-up window called GWSDAT Options appears. You can use either the default parameters, or you can modify each option from the drop-down menu via the arrow to view and select a different parameter. Model output interval has the settings for the spatiotemporal model prediction interval. Day means that the concentration and groundwater elevation contour plots are generated for every date represented in the input dataset. This is especially good if you are monitoring an event comprising of a short amount of time. Month generates the contours at monthly intervals, working backwards from the latest date in the input dataset. This aggregates groundwater elevation data within each monthly interval so that a larger set is available for plotting elevation contours. Quarter generates the elevation contours quarterly, working back from the latest time in the dataset. This aggregates in each 3-month period so that a larger dataset is available for plotting elevation contours. Note that both monthly and quarterly only aggregate the dataset used to plot the groundwater elevation contours. The solute concentration set is not aggregated in the time period. Please also note that if no monitoring data is present within the particular monthly or quarterly interval, then GWSDAT will not generate a groundwater elevation contour or spatiotemporal solute concentration smoother plot. This is to avoid misleading spatial plots far removed from actual data. The groundwater level aggregation method. In the event that there are multiple groundwater elevation measurements from the same well in a given output interval, such as month, the user can select how this data is used, either the mean of the data, the median of the data, the minimum or the maximum of the data for the groundwater elevation. Non-detect handling method is how we change how GWSDAT handles non-detect data by substitution. You can either select that the substituted value is half of the detection limit or the full detection limit. And finally, model resolution. This option controls the resolution of the spatiotemporal model. Normally, the difference between default and high is minimal, but in particularly complex datasets, the high resolution may be necessary. Note that the higher resolution takes approximately 2 to 3 times longer to fit. Let's press OK now, and it will begin to analyze our dataset. Here we can select which aquifer we're using. Because we use the complex example, we do have the options of the blank aquifer or Aquifer A. In case NAPL data was used as part of the input, which again it is in this example, another pop-up now appears. The data contained NAPL data, aka data with NAPL entered in the constituent field. We can select yes, which forces GWSDAT to recognize NAPL data in the input dataset as indicative of high dissolved solute concentrations. This provides the user with a more realistic picture of the area of impacted groundwater in the event of NAPL in wells preventing direct measurement of solute concentrations. Before doing this, one should be confident that the dissolved solutes are derived from observed NAPL and not a different source. We'll now finish fitting the data, and once the data has been fitted, we can now see the analysis page of GWSDAT, including a spatial plot, plume diagnostics, well redundancy tools, time series plots of wells and solutes, traffic light plots of thresholds, and well report matrices. All of these and more are covered in section 4 of the videos, starting with video 4.1, the spatial plot. Thank you very much for watching this video. If you enjoyed, please feel free to like and subscribe. And if you have any feedback or questions, there is a link to a feedback form in the description.